Hello, I'm Eric Snodgrass, and thank you for watching today's long-range technical forecast video for Australia, brought to you by Nutrien Ag Solutions. This analysis is being provided for perspective only, and any decision made based upon this presentation is the sole responsibility of the person making the decision. Finally, please remember that all long-range weather forecasting is speculative by nature. Well, one of the most amazing inventions that came out of World War II was the invention of the Doppler radar. And that animation you see over there on the left shows you how it works. So inside of that dome, there is a dish, and it produces a microwave signal that we blast out in kind of this radial form away from the dish. Now, when it bounces off of stuff like raindrops, we get a reflection, and we can actually then tell where the object is, how big it is, or how many of those objects there were, which makes it an ideal instrument for counting raindrops. And if we count them, we know how many there are, and therefore we know how intense the precipitation is. Now, the radar scans across a wide range of heights, which is the image that's over there on the right, and allows us to get kind of a full profile view of nearby, precipitation. And the radar in Brisbane captured, national and international attention over the weekend. This animation right here was a cluster of storms that was passing over the radar. And what I want you to see as you watch this was some of these storms right here, I'll just pause it, showed these deep reds indicating very heavy rainfall, but also some pinks. You see, the image you're looking at is called a radar reflectivity image, and that's basically what the colors tell you, how intense the precipitation is. And many of you know that as you get toward the reds and eventually into the pinks or the purples or whites, you're seeing very, very high reflectivity. But you notice the very distinct break between red and pink right here? Well, that value is 60 decibels of reflectivity. And why there's a distinct break in the color bar is because at that point, if we scan anything where the reflectivity is greater than 60, we know we're scanning through hail. And you can see the hail cores in several of these storms. Now, if you want to know what radar app I like to use, it's called RadarScope. RadarScope. Feel free to check it out. And in this particular image from RadarScope, we were seeing some very large hail. And your national news media shared the video over there on the left, all over the world actually. And those the holes in the roof there are from hail. Now, in the United States, we measure our hail size either by comparing it to the size of fruit or to the size of sporting equipment. So we'd call this softball-sized hail or grapefruit-sized hail. And that stone you see over there is one that went through her roof and landed in her living room. And images like the one on the right spread wildly through social media, showing us some of the damage to the rooftops. So this was a pretty rare event. Now, the beauty of radar is that we can cover a large area and therefore measure total accumulated precipitation. So this particular event, while we saw all this hail, also helped us make the map over here that you see from BOM. Now, what we get is we get data of rainfall from rain gauges, and then we also get it from radar. And we can combine those products to give us the map you see here. Now, when we look back over the last week, so this is the week ending on November the 3rd, in some locations down here in parts of New South Wales and then along the East Coast, we saw some very heavy precipitation. You can even see right here better than 100 millimeters of rain from some of those heavier thunderstorms. Now, the forecast, the week 2 forecast, which was predicting this, which I showed you last time, picked up on that actually quite well. Where the model failed, though, was over here. When predicting normal precipitation, maybe even slightly drier than normal, what we ended up getting was some locations here picking up, better than 10 to 15, maybe upwards of 25 to 30 millimeters of rainfall from that last system that snuck through there. Now, I'm going to show you what that did to soil moisture. Looking at the top 10 centimeters here, this is root zone soil moisture. I pulled this map off on November the 1st. We were still seeing in those top 10 centimeters some dry conditions in parts of Western Australia. But the rain that came through, look at what it did. It brought those values now back to be above normal in that area. But remember, the top 10 centimeters, that can be evaporated very quickly. So this is usually a map that changes quite a bit unless you're replenishing the moisture quite routinely. So I'm going to take a look at some deeper moisture here. Let's go down a meter below the surface. Here we're looking at deep soil moisture values, and we can still see that there are large sections of Western Australia and even parts here through South Australia into Victoria and even parts of Queensland that are still showing up dry a meter down. All right, so this is just kind of giving us some perspective on soil moisture. So let's see if we're going to be replenishing that anytime soon. And to do that, I'm going to go straight to the operational European model. To begin things here on Thursday, we did have some precipitation right here along the coast, pushing up against the higher elevation here at the headwaters of the Murray River, for example. As we play this forward, this is going to move to the east out of New South Wales. You'll see it there getting out pretty quickly. And behind it, higher pressure moves in. Let me just take you back and show you that again. So working our way through Thursday, into Friday, what we do notice is that in addition to that rain leaving, we do have the chance for some scattered showers right here over this part of Western Australia. Going forward, though, through our weekend, it's going to be relatively quiet through the weekend. Just some scattered showers here in parts of Western Australia, but not much in way of accumulating precipitation. I'll show you the amounts in just a few moments. Here I am getting into Sunday. Still large area of high pressure occupying much of parts of Victoria, Tasmania, South Australia, and New South Wales. And what we're going to be watching is for early next week on Monday for our next system to start to take shape. You can see that on Monday, we're expecting to spread some lighter rain here down in this part of Western Australia. But going from Monday into Tuesday, that low pressure system really begins to intensify. And you can see the associated front right in through here, through which we might possibly be bringing in some heavier precipitation amounts through South Australia. And then eventually, once we go from Tuesday into Wednesday, into parts of Victoria, Tasmania, but also coming up in New South Wales with that front extending into Queensland. And that passes on through. Behind it, we've got some cooler air, higher atmospheric pressure, and yet another system at the end of next week that could possibly be bringing in some precipitation here into parts of Western Australia, as well as showers and storms once again over here along the East Coast. Now, thinking about that, what I wanted to do next is I wanted to just know how robust of a solution that large low pressure system coming in on Tuesday was going to be. So we're looking here at the European ensemble forecast. In other words, each one of those L's is the model from 51 different simulations putting its position of the low pressure center. And you can see pretty robust solution here suggesting that right here is going to be the center of that low on Tuesday, meaning that the forecast of rain I just gave you looks to be pretty robust. We can also see a secondary low here moving through this part of South Australia. So accumulating precipitation. Over the next 12 hours, we are certainly going to be able to pick up possibly somewhere between, upwards of maybe 20 millimeters of rain as the first low begins to exit. As we then go through the next couple of days, you can see the scattered showers right here pulling through parts of Western Australia. Again, we're talking about amounts here that are generally going to be between 10 and 30 millimeters. So the first system exits, here comes the second system. Now as we work our way from Friday into Saturday and Sunday, this is where we start to watch the formation of that deep low. So now here we are on Monday, and it's going to start to move, bringing its front first through Western Australia, adding up a little bit more with some scattered rainfall here. And then going from there into Tuesday and Wednesday, that's when we start to see the increased chances of precipitation for South Australia over into parts of Victoria, Tasmania, and as well as parts of New South Wales. Notice the first system goes over here and hits New Zealand hard. Some locations are picking up 100 to 150 millimeters of rainfall, of course being enhanced by the mountains. And as we work this out into the end of next week, we see here's our total look at precipitation really through the next 10 days. Now, overall, these amounts are relatively light compared to what we could be getting this time of year. But let's take a look at this by comparing it to what the BOM is saying. Generally, a pretty solid picture here comparing the two output. Where the European model is wetter is generally right in through this area, but seeing rainfall amounts here between 10 and 20 millimeters over in Western Australia, and then between 10 and 30 millimeters over in this part of New South Wales is consistent between the models. Now, beyond that, to understand where the pattern's going, I want to take you first to what the MJO is doing. Remember, the MJO has 8 separate phases, and they're defined for you over in the maps on the right. Well, the MJO is currently sitting weakly in phase 7. It's going to pop out in phase 8, 1, and 2. Now, those phases, as you can see here, are typically dry just north of Australia. There's phase 8 and 1. But by the time we get over into phase 2, we start to see the precipitation moving into the Indian Ocean. And going from there into phase 3 and 4, which is what we'd expect this to do, that's going to increase the chances at the end of week 2, getting into week 3 and week 4 for increasing the precipitation amounts. So I just want to show you what one piece of the flow is doing here, that being the Mad-Julian Oscillation. The second thing is the southern annular mode. Now, Now, since the end of November and the end of October and the beginning of November, the southern annular mode jumped up into positive territory. Over the next 10 to 15 days, it's expected to return toward normal. Now, when it goes positive, just remember that in the month of November, positive NAO corresponds to wet conditions. Positive AAO, or southern annular mode. It corresponds to wet conditions along the east coast and also wet in the north, as well as this section of Western Australia and South Australia. So this is what the southern annular mode gives us this time of year. We expect it to go back toward normal, though. That's why when you look out into the week 2 time period, it might only be the return of moisture here from the MJO where we see wetter conditions. Much of the rest of the continent here is probably going to experience near normal to drier than normal conditions into week 2. The GFS model is way more aggressive on bringing moisture back in here, but I'm going to tell you something, it's the outlier. So if we could just do this, I would say focus much more on the map over here on the right. And here's the good news. When I present to you next time, we'll verify which of these two models did the better job. From there, I'd like to talk about temperatures through the next 10 days. Over here on the left, as the first system exits and heads toward New Zealand, where it's going to put down a lot of heavy rain, we do have some cooler air that will be behind this, generally 1 to 4 degrees Celsius below normal. But then there's going to be a warm-up. And behind that, though, with that next system, remember that low that was going to be forming right in through here, we will get some colder air in the day 5 through 10 time period as high pressure builds in on the backside. And that colder air back there may be generally 4 to 10 degrees Celsius cooler than average coming into Western Australia. From that point forward, I'd like to show you what things look like mid-month. Both the long-range European and the long-range GFS model really want to bring in just broad-scale warmer than average conditions by a few degrees. So this is the model really saying that as we go now toward the end of our spring and then eventually into summer, we're going to be seeing temperatures generally here mild, warmer than average. What about precipitation though? Well, let's look at it 2 different ways. Over here on the left, this is the European model's forecast from November the 15th through December the 15th, that whole month. And we're seeing wetter than average conditions spreading in through this area. And I think that's largely going to be due to the movement of the MJO. Interestingly enough, the European model is trying to paint a corridor in through here of drier weather, as you see right in there. Now, is this a solid forecast? Is it robust? Do I have a lot of confidence in it? No, I do not. And that is because at this particular point, I'm seeing too much interplay between the southern annular mode, the MJO, and La Nina. And unfortunately, the 3 of those things are not being constructive right now. In other words, they're not adding up. But the Bureau of Meteorology for the month of December is still forecasting wetter conditions along the coast and also wetter down here in this part of South Australia and the eastern side of Western Australia. That's the probability of exceeding median rainfall, still relatively high. From there, let's talk about that La Nina. Now, I want you to know something. While it is still strengthening, it's temporarily kind of stalled out. You see, it got down here where the ocean temperatures in Nina region 3.4, which are inside this box I'm drawing, where they got down there to 1.5 degrees Celsius below average. But we've since then kind of stalled out. After much of the month of October, we were watching it drop off precipitously, really, really quickly. The Indian Ocean is still quite warm, as you can see here. All right. Now, what does all this mean? Well, what it means is the Bureau has kind of kicked the can down the road here. And instead of allowing the La Nina to peak in December, they're now allowing it to continue to strengthen into January before starting to go back toward neutral conditions once we work our way through summer. And that's an interesting near-term shift. Now, at this particular point, we are waiting on all of the brand new long-range model updates here at the beginning of the month. And I'm going to get them soon. I'll analyze them and report them back to you. But so in the meantime, I just want you to remember what we had previously forecast for December, January, February. This was what the Bureau was suggesting, and this is what the European model was suggesting. Very similar forecasts, both calling for much of the continent to experience above average precipitation, especially here along the East Coast. So remember, this particular forecast is dominated by La Nina, and I'm excited to get some of that new data and report it to you. As soon as I get it, I'll put it out in a forecast and make sure that you see it. A couple things to point out though, do notice the differences down here in Tasmania and also in New Zealand. There's some interesting anomalies there I think we should be discussing as well. We'll wrap it up right there. Thank you for your attention. Look forward to talking again in a couple of weeks. Have a good one.